Take a look at this figure. From this figure showing on your screen, can you prove that the acceleration due to gravity is approximately 10 meters per second squared? I believe you are now curious. In this video, I want to show how the generally accepted value of acceleration due to gravity is 10 meters per second squared. If you studied physics, you want to watch this video to the end. It is very interesting and educative, and you don't want to miss any part of it. Before we continue, let us put context to this image or this figure by bringing up the question that probably gave rise to this figure so that we can put context to the whole thing. Watch this. So this is it. We are given that the mass and radius of the Earth are 5.972 times 10 raised to the power 24 kg and 6371 kilometers respectively. Show that the acceleration due to gravity is approximately 10 meters per second squared. Take gravitational constant G equals 6.6743 times 10 raised to the power minus 11 Newton meter square per kilogram squared. So this is what gave rise to that figure. And these values here, the mass of the Earth, the radius of the Earth, the gravitational constant, they were not made up by me. They are constant values. You can simply get them by Googling them. Just search online, search the radius of the Earth, you will see this value. Search for the mass of the Earth, you will see this value. Search for the gravitational constant, you will see this value. So I didn't make them up. I just searched them online, got the fixed values, the constant values for these various parameters, and put them into this question. So now we have these values. We want to use it to show that the acceleration due to gravity is approximately 10 meters per second squared, because we have so accepted this, but some of us don't know how it came about. That is what this video wants to demonstrate. It is a bit long, but believe me, if you watch to the end, you will be entertained, you will find it interesting, and you would have been educated about this. Now take a look at this. This is the Earth. We are told that the mass of the Earth is this value according to the question. We want to show that the acceleration due to gravity is 10 meters per second squared. How did we get 10 meters per second squared? We know that when you throw something up, or whatever goes up must surely come down. That means that there is a force that pulls every object that leaves the surface of the Earth back to the surface of the Earth, which means acceleration due to gravity is usually of an object that leaves the surface of the Earth. It means in this question, we need a test object. Before we go to the test object, we are told that the radius of the Earth is 6,371 kilometers. So let's just have it in this figure here. Radius of the Earth, 6,371 kilometers. Now we need a test object, like I said earlier, to show that the acceleration due to gravity on that test object will be 10. Let's call the test object a mass of 400 kg. If this is our test object and it has a mass of 400 kg, we are going to prove that it has an acceleration due to gravity of 10 meters per second squared. The mass of 400 kg is just an arbitrary value. That is the value that came to my head. You can use any value. You can use 800, 1000, 2, 20, 5, 6, 80.2, just any value, because the thing is that anything that goes up must surely come down. So make up any value you want to show that anything at all will give you 10 meters per second squared. It does not have to be 400. I just picked 400, right? So if we're on the same page, let's continue. Now, there is a distance between the surface of the Earth and the center of that object. Let's call that distance D, right? Between two objects, there is a force of attraction that attracts these two objects due to gravity. In this case, we have the Earth and we have the test object. That means there exists a force that pulls these two objects together according to gravitational theory. However, The Earth is so massive, you can see the mass here, when compared to any other object that is on the surface, which means if there is a force of attraction between these two, you do not expect this object to pull the Earth towards it. It is the other way around. It is the Earth that will pull this object towards it because the Earth is so massive. If that is the case, that means there is a force with which the Earth always pulls object that goes away from the surface back to its surface. Mathematically, that force is given as F equals to Gm m all over r squared, where G is the gravitational constant, the uppercase letter m is the mass of the Earth, the lowercase letter m is the mass of the test object, while r is the distance from the center of the Earth to the center of the test object. So we can say that in this scenario, r will be equal to uppercase letter r plus d, r plus d, because it is the distance, the radius of the Earth, plus the distance from the surface of the Earth to the center of the test object, d. So r, lowercase letter r, is equals to r plus d. Now it's getting interesting. Be patient. If you look at it carefully, the value of d will be negligible compared to the radius of the Earth. We are talking about a massive value of 6,371 kilometers. What do you think can be suspended above the surface of the Earth that will be as close to the radius of the Earth as possible? Almost nothing. In fact, if you go 400 kilometers away from the surface of the Earth, you will experience a lesser gravitational pull, which means that d is so small when you compare it to the radius of the Earth. In other words, we can say that the radius of the Earth, r, is far greater than d. And if d is very small, it is negligible. It means we will assume we are not seeing this d here, so that the radius r, or the distance r, will simply be equal to the radius of the Earth, because d is negligible when you compare it with this value. So which means the radius of the Earth will simply be, the radius or the distance r will simply be the radius of the Earth, 6,371 kilometers, just as we have it here. However, I have converted it from kilometers to meters, and that is why you are seeing it as 6.371 times 10 raised to the power 6 meters. That is the distance we are now taking, because d is negligible. Realistically, it is negligible compared to the radius of the Earth. We are getting there gradually. You can see we found all of the values that fit into this equation. So let's proceed by finding the force of attraction with which the Earth will pull this test object towards its surface. So F will be equal to this, to represent G, as you can see here, times the mass of the Earth, uppercase letter m, times 400, the mass of the test object, divided by r, 6.371 times 10 raised to the power 6, all squared, because the radius is squared in the formula. If you put the numerator into your calculator, you will obtain 159435 times 10 raised to the power 12. If you square the denominator or put this value into your calculator, you will get 40.59 times 10 raised to the power 12. 10 to the power of 12 can cancel 10 to the power of 12. And this divided by this will give you 3928 Newton. It means the force with which the Earth will pull a mass of 400 kg towards its surface is 3,928 Newton. We are getting there gradually. Please relax and watch to the end. Now we know the force. We are not looking for the force. We want to know the acceleration due to gravity of this object and check if it is equal to 10. So let's recall that force is equals to mass times acceleration. In this case, acceleration due to gravity, g. Since that is what we are looking for, let's make g subject of formula by dividing both sides by m, so that g will be equals to F, the force, divided by m, the mass of the test object. Let's put values. G will be equals to 3928 divided by 400. And if you put this value into your calculator, G will give you 9.82, which is approximately 10 meters per second squared. Hence, we've successfully proven that the acceleration due to gravity will always and always be approximately equal to 10 meters per second squared. If you like, change this to any figure. You will come back and arrive at this answer. Put any figure here. In fact, try this. Choose any test mass except 400 kg because we've used 400 already, and confirm that the value of G will still be approximately 10 meters per second squared. And when you do that, kindly put it in the comment section and I'll be there waiting for you. So you can see that this value that is universally accepted can actually be proven to be correct. And that is what we have done in this video. I believe you enjoyed this video since you watched it to this point. Thank you very much for watching this. Please like, share, and comment on this video. Keep encouraging us to make interesting content. Once again, thank you for watching and see you in our next video.